Hello, beta. Hello, 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 hello. Am I audible and visible to all of you? Sir, not able to solve homework questions or anyway. Good evening. Good evening, beta ji. Good evening. One second. Yeah, my voice is fully audible and I am visible as well. So I have given you some homework, right? So I given you one question other than academies. Yes, so you can ask me now. Couple of minutes, right? 1 2 minutes. I will just give you the answer. Okay, don't worry about it. Okay, how to increase willpower? It simply gets, look, if you want to get something, na, so willpower shows you how badly you want something. Okay, just like you want to be the doctor, right? So you need to think about the reason why you want to be the doctor, or you want to be the engineer, right? You need to ask a question to yourself now, why you want to be an engineer or doctor, right? If you have a very good goal, if you have very good aim, that automatically will give you the very great inspiration and great willpower for that thing. Yeah, in the starting phase or in the initial phase of your preparation, it is very hard to be the consistent, steady, hard, right? Because you will see your lot of friends now who are enjoying their lives, right? But you need to just look towards the society and the reality that yes, if you want to enjoy your life, okay, so you need to just dedicate some time to build your career for that. Okay, so what you need to do now, you need to be very and very, very disciplined about your studies, extreme discipline. So let us suppose you have 24 hours. In 24 hours, you need to sleep for 6 to 7 hours. You need to be in the school for 6 to 7 hours. Okay. You need to study for 7 hours, right? 7 to 8 hours. Then 1 hour or 2 hours you need to break for your gaming or gymming or all these kinds of activities. And you need to maintain this kind of timetable throughout your journey. It is difficult. It is most difficult thing because your age is not enough mature, right? You are not enough mature right now. You are in 11th or 12th, mostly 16 and 17 years kid, no? Because you will see your friends now who are just enjoying their lives, right? By doing some different activities. So to maintain your these kind of things out of doing the enjoyment thing, it is very hard. But if you pass this stage of your life, no, everything will be sorted for you. If you can check the reality of jobs in India, no, so automatically you will get very great inspiration from that thing. If you want to enjoy from 19 age or 20 age, okay, if you want to earn some money in your earlier age, so that you can just enjoy your whole life, you need to dedicate some time, no. It is not someone will come and he will be giving you some kind of job, no, in the future. You need to be the great candidate for that thing. I'm scoring 150 out of 300. How can I improve? Okay, for any examination, no, for any examination, first of all, you need to study from your teachers honestly. If you are very disciplined and if you have very great honesty regarding your studies, that is first thing. Now, second thing is you need to do your homework, maintain your notes, do homework, DPPs, module. Okay, only these things. Okay, class from your teacher. You need to blindly trust your teacher. Don't just do many books. Okay, be concise. Then second one is you need to do your homework, DPPs, your module. After that, your NCRT. these 5 steps, these are more than enough. Then everything will be getting sorted. Okay, nothing is impossible. Yeah, but it will take time. For some kids it takes less time, for some it will take more time. Initially it will take more time for all of you, no? But with the time, 2 3 months, 4 months, right? Definitely your numbers will get improvised, no? You need to firstly check your weaker portion. If you are having many subjects, no, or in a single subject if you have many sects, okay? So you need to just firstly uh, think about which portion is your weak. You need to analyze your numbers, right, from a particular your tests. After analyzing your weaker portion, you need to do some more hard work for that particular chapter. Whether you lag in your basics, okay, you need to just think about why I am lagging in chemistry, let us suppose. Okay, then you need to work more hard for that thing. Let us suppose you are having a numerical. Suppose I will give simple numerical. You are having a numerical. We have a some sort of hemispherical bowl. Okay, in hemispherical bowl, in one end we are having a charged particle. That charged particle is moving downwards. Find normal reaction force. One. Okay. Second part. If you are introducing the magnetic field also there, then you need to just get your normal reaction force. So you need to relate your things. Okay, from 11, from 12, you need to relate these things. And the only way by which you can relate it, na, that is your presence of your mind during your classes. Okay, I guess we have discussed more than enough. Now let us talk about our own chapter. One second, one second, one second now. Okay, so which homework? This one, na? This one is simple, right? Look, beta. Look, symmetry. Symmetry means we need to cut it from this particular portion. Now look, this is symmetry. Now Citrajit, it gets cut like this now. So you will have now new thing. It will be looks like this. Look now. It will be like this. Okay, it will look like this now. Now easy, right? Now this one is easy. How, sir? Look now. Look here. R 2 R, R 2 R, R 2 R, 2 R. Now these two are in the parallel. So their R equivalent came out to be R. R equivalent came out to be R. Okay. So look now. If I need to just redraw the whole structure, it will look like now this. Look. 1, 2, 3, 4. About this, so I will write like this only. R, 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 and R. Done. So look, 3R, 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 3R in parallel. So my R equivalent came out to be R. Easy, no? At the end of the class, na, I will give you more time, right? Or you can do one thing, na, beta. What's your name? Sundaram Srivastav. You can do one thing now. You can join my Telegram group. In my Telegram group, you will find my personal username. You can ping me message there. I will be doing a mentorship about how to just improvise your Shakoor. Okay, don't worry about it. Okay, simple homework question. You can just check out your mistakes. And here, if I can see now, my previous students, they didn't join the class. Okay, look now, this is the discipline. Na? Look, beta, you are coming in the class from first class. Now you're maintaining your consistency. In every day, you will get something new from my classes, right? That's why if you are watching my first class, then fifth class, then eighth class, you will get nothing from my classes. It is waste of your time. If you really want something, now you need to just watch the whole things. Okay. Now in this class, we will be talking about the switch. Okay, part switch. Look, it is just basically of how to deal with the numericals, right? One more parameter switch, how we can have it deal with different numericals. Let us suppose we have a system like this. Now look, okay, with V, now 2R resistance R, 2R and R. Suppose here we have a wire like this. Now look, wire. Okay, you can see from this particular figure, this wire, na, some blue color wire, it is not touched. So no current will flow from this one. So you can see, sir, now I can tell that these two are in series and these two are in series. Done. So what will be the equivalent of this one? It is 3R. And equivalent of this one, it will be 3R. 3R and 3R. Done. So, but if I need to just maintain it now, look, 3R is 3R, 3R, V. So what is R equivalent? Sir, R equivalent came out to be 3R into 3R divided by 3R plus 3R. It will be 3 by 2R. It will be 3 by 2R. Then what will be the I? Okay, what will be the I, sir? We know that V is equals to I times R. So I came out to be V by R. V is V. What is R, sir? R is 3 by 2 times R. Okay, so I think I can write it 2 by 3 times V by R. Can I write like this? Yes, sir. What is 2 by 3? I guess it is 0.67. Yes, 0.67 V by R. Look, it is open here now. You can see this one. It is open. So you can write, sir, it is open now. It is open. This one is open. If my switch is open, if my wires, they are not in touch, you can call it as an open switch. If my wires are in not touched, na, you can call them what? As an open switch. Now, if I close this one, second part is if I now close this switch, what will happen now? Look, what will happen now? Look now, beta. V, this one R, 2R, 2R, and R. Now here, this is my switch now. Now I will just connect this one. I will now connect this one. If I now connect this one, so what you can write now? Look, potential of this one, potential of this one, and potential of this one will be same. Okay, so you can write it now. You can write the same thing like this now. Look, it will look like this now. It looks like this now. V R 2R 2R and R. So what will be the R equivalent? Sir, 1 by, or I can write simply R equivalent came out to be 2R into R divided by 2R plus R. It is 2R square divided by 3R. Cancel out, it is 2 by 3 times R. So the R equivalent of these two given to be 2 by 3 times R. R equivalent of these two will be 2 by 3 times R. Done. So I can write it like this now. Look, Okay, simple na. It is 2 by 3 times R, 2 by 3 times R, 2 by 3 times other chalo beta, 2 by 3 times R. So you can see from this one na, it is 2 by 3 now. 2 by 3 R, 2 by 3 both are in series, so you will add it. So it will become now only like this, no? 2 by 3, 2 by 3. So what is 2 by 3 plus 2 by 3? Sir, it is 4 by 3. It is 4 by 3 times R. So if you want to now find I, if you now find this I, sir, I is equals to how much? It is V by R. I. V is V. What is R? Sir, R is 4 by 3 times R. I can write I came out to be 3 by 4 times V by R. I. What is 3 by V? It is 0.75 V by R. So this condition means, thank you, beta, thank you. Okay. So now you can see here. Now look, you can see here, sir, my switch is closed. If this switch is closed, now switch closed, right? Then now open switch, closed one. Or you can write, sir, off switch, this is on switch. So you can see when my switch was open now, my answer was 0.67. And when my switch was closed, my answer is 0.75. So it simply indicates that after switch closed, after switch closed, then current increases. Okay, so from this calculation, we conclude that if we are closing the switch, the current will open. Sorry, the current will increase. The current will increase. Done? Done now? Okay. Now I will just give you one sort of idea now how to write the potential difference. Okay. Suppose we have something like this. We know that the long mean is positive. Long mean is positive, the shorter mean is negative. Shorter mean is negative. The long mean is positive, shorter mean is negative. And we can write that if the potential of the bigger one is VB, the potential smaller one is VA. So what will be the delta V? Sir, it will be VB minus VA. It will be VB minus VA. Done? And if let us suppose it is given to us, suppose we have a question. Suppose we have a question. And my question is, we have a battery or a generator like thing, right? And delta V. And delta V is given to us 5 volt. Delta V is given to be 5 volt. You need to comment on what can be the values of VA and what can be the values of VB. Okay. So look better. Look, every time delta V is 5 volt, it won't change. It is 5 volt. It is 5 volt. If somehow we are saying that, sir, my VB is plus 5. So which number I need to add so that I will get 5? So I will write 5 plus 0. Look, delta V now. So delta V is VB minus VA. So if VB is 5 minus VB is 0, I will get 5. If it is 5 now, if somebody will ask you, if my VB is 3, what will be the value of VA? Sir, my delta V is equals to VB minus VA. Delta V is 5, VB is 3 minus VA. So I will write, sir, VA equals to 3 minus 5. Sir, VA came out to be minus 2. Minus 2. It should be minus 2. This is how you need to check your VB potential of first kind of rod and second rod. Okay, done. Or many examples, many examples. Let us suppose my VB. If my VB is 10 volt, so what will be the VA? Sir, 10, it will be 5 then. 10 minus 5 will be, delta V will be 5 volt. Or if my VB is, let's suppose, minus 5 volt. What is VA now? Sir, we know one thing, delta V is equals to 5 volt and delta V is VB minus VA. It is 5. VB is how much? VB is minus 5 minus VA. Clear? It is minus 5, no? Yeah. So what I can write here? Sir, I can write VA equals to minus 5 minus 5. It will be minus 10. Yes or no? Yes or no? Huh? Clear, no? This is how you need to do. Let us suppose one more thing now. Let us suppose we have a structure like this. No, look, this one. This is my structure. And one thing we know, sir, delta V is 5 volt. So comment on VB and VA. Comment on VB and VA. Sir, how we can do it? Look, this particular thing known earthening. Okay. So this part we had done in what? Electrostatic. And earthening means it creates the potential 0 volt. That simply indicates if it is VB and if this particular slide is earthening, so VB will be how much? Due to earthenings are 0 volt. What is VA? Sir, delta V equals to VB minus VA. Delta V is 5, VB is 0 minus VA. So VA came out to be minus 5 volt. VA is minus 5 volt. Or we can do one more now. Let's suppose we have like this structure now. We will do the earthening of this one now. VB and VA. Delta V is 5. Comment on VA, VB. Look, earthening side will be 0. So VA is 0. So VB will be how much? Sir, plus 5 volt. It is plus 5 volt. So now the reason why I just told you this thing now, so that you will get an idea if my earthening is done, so what will happen? What could be the possible result of these things? Because when we are doing KVL and KCL, so we need to get this idea, no? Done? Okay. Suppose I will give a question now. Based on the same thing, I will give a question now. Look. And I want you that give me an answer, a correct answer for this one now. Give me the values of V1 and V2. Give me the values of V1 and V2. Huh? I will give 2 minutes, na? 2 minutes, beta. 2 minutes. Okay, give me the answer. Which potential is zero? Look, so this mean is zero. So, sir, potential at this point will be 0 volt. 0 volt. Okay. Now, what will the potential V1? Sir, if my current I is flowing, sir, my I is flowing, it is series combination. Now, you can see it is series combination. In series combination, I is same. I is same. If I is same, so V equals to IR. I same, so V proportional to the R. V is proportional to the R. I guess in previous class we concluded one topic known as potential division method. Okay, and the answer was, sir, V1 equals to R1 divided by R1 plus R2 into V. R1 is 4 divided by 4 plus 6 into 60. I will write 4 divided by 10 into 60. Done? No, it is not like that, sir. Why? Because the reason is here is 0 volt. Okay, so here is 0 volt. So you can write, sir, the V is proportional to the R. So the ratio V4 ohm is to V2 ohm. It will be in the ratio of 2 is to 1. 2 is to 1. It simply indicates this V1 will be equal to how much? 40. It will be 40 ohm. Sorry, 40 volt. And the V2 will be how much? 20 volt. Not 24. With 20. Because why? Because here is 0 volt. Sir, simply indicates if it is 0, so this point will be minus 20 volt. If this point is 0, so this point will be plus 40 volt. So this one is how much? Sir, this one is plus 40 volt. And this one is minus 20 volt. And what is delta V? Delta V is how much? It is VB minus VA. VB is 40 minus VB is minus 20. It will be 40 plus 20. It is 60 volt. It will be 60 volts. So you need to do the numerical like this way. Sir, why are we can use that formula now? You can do that thing also, no? Sir, it is 4. 4 divided by 6 into 10. Look, so 60. 10, 40. We got the 40 for this one. Okay, now we will start now. Kirchhoff's law. What do you use now? What is the timing now? Oh, we have 1 hour now. Kirchhoff's law. We have Kirchhoff's law. Okay. The potential of this one point is 0. This one is 0. Not this one. This one is minus 20. This one is plus 40. Now we have now Kirchhoff's law. So in Kirchhoff's law, our syllabus is KVL and KCL. KCL we will firstly, then KVL. So we will discuss one by one. Okay. First one is how much? KCL. KCL, first law. So it is also known as first law. KCL known as of the first law or current law. First law, current law, junction law. Junction law. Done? Or shortcut KCL. Kirchhoff's current law. So how many names we have? Three names. First law, current law, junction law. So look now, what is the law all about? A state is that, let us suppose this is my first wire, second wire. Okay. If current I1 is coming and here I2 is coming, we have a third wire. If I1 is coming, I2, what is the current coming to this particular point? What is the current coming to this particular point? Sir, current is coming I1 plus I2. Law clear is that the incoming current must be equal to the outgoing current. So I3 will be equal to I1 plus I2. Okay. Or you can write here, what sir? You can write here incoming current is equal to outgoing current. Shortest statement. Incoming current equals to outgoing current. Incoming current, we can denote it with negative letters. Outgoing means positive. Incoming sign convention. Incoming means negative. Outgoing means positive. And you can write summation. It is summation of current at a point is 0. Summation of current at a point is 0. Done? So it is what? Kirchhoff's current's law, that incoming current must be equal to the outgoing current. So in a particular junction, the summation of current is equal to 0. Incoming current, we can take it as a negative, outgoing current as a positive. Most important thing, and it was asked in NEET also. That is, it is based on charge conservation. Based on charge conservation. Clear? This one is important. This term is important. This one. So it is based on the principle charge conservation. The incoming charge must be equal to the outgoing charge. So now we have the idea regarding what KCL is. Okay, this is more than enough regarding the KCL. Now, sir, how to apply the KCL? Now, how to apply the KCL? How to apply the KCL? Look now, I will show you one numerical by which you will get the idea how to use the KCL. Look now. Clear? This point is 12 volt. This point is 2 volt. This point is 30 volt. Okay. This resistor is 10 ohm resistance. This one 20 ohm. This one 30 ohm. Done. So what we need to find? First part, find potential. Find potential at common point. Find potential at common point. First part. Second part, find current. Find current in all branches. So these two things we need to find. First one is potential at common point. Which one is common? Sir, I guess this one is common. If this one is common, so mark it as X. If this one is common, mark it as X. Clear? And we need to apply KCL this point. So apply KCL. Apply KCL. Sir, what is KCL? I guess KCL means current which will flow through 10 ohm resistor plus current which will flow in 20 ohm resistor plus current which will flow in 30 ohm resistor. It is summation will be equal to 0. Why, sir? According to the KCL, summation of current at a particular junction is 0. Done? Sir, what is current now? Sir, current is equals to delta V by R. Delta V by R. Sir, what is delta V? It is potential difference. Okay. Now 10 ohm. 10 ohm means it is delta V by R. Delta V means 30 minus X. We are supposing it now 30 minus X. So I will write 30 minus X. Take it as a smallest. So I will write it as a smallest potential. Potential means higher minus lower. So it is 30 minus X divided by R. R is how much? 10 ohm. Plus 20. 20 means higher minus lower. So is it 12 minus X? Yes, sir. 12 minus X divided by 20 plus 2 minus X divided by 30 equals to 0. Equals to 0. Okay. I am not in the frame now. Let me check. I am not the frame, right? One second. Yeah, I am in the frame now. Yeah. Okay. So now do the multiplication things. Look, beta. What I can do, I will take 0 common. Now I will take 10 common. If I take 10 common, I will write 1 by 10. Okay. Next numerical, I will be doing a shortcut way. It is 30 minus X plus 12 minus X divided by 2 plus 2 minus X divided by 3 equals to 0. I will take 10 this side, it will become 0. It will become 0. Now it is 30 minus X. 30 minus X. I will do cross multiplication, right? Multiplied with 2 plus 12 minus X multiplied by 1 whole divided by 2 plus 2 minus X by 3 equals to 0. It will be 60 minus 2X plus 12 minus X. Now one more time I will do the cross multiplication. So it becomes now multiplied by 3 plus it is 2 minus X multiplied by 2 then whole divided by 6 equals to 0. Yes, known unknown. So what it will be equals to 60. Now look here. I will do now. Look, it is 300 180 minus 6x plus 36 minus 3x plus 4 minus 2x equals to 0. Okay. I will write 180 plus 36 plus 4. Done. Plus minus 6x minus 3x minus 2x equals to 0. Plus minus. One second. Okay. So 40 220. 220 minus 11x equals to 0. So x came out to be 220 divided by 11. 120. I guess it is 20 volt now. X came out to be 20 volt. So here I will write X as a 20 volt. Okay. So this X came out to be how much? 20 volt. 20 volt. Look now, current flows from high to low. It simply indicates, no, I will do the calculation, then you will get your own. Na? So look now, this is I1, it is I1. Is it 30? X is 20. 30 minus 20 divided by 10. 10 minus 10 is 1. It is 1 ampere. If it is plus 1 ampere, so my direction is correct. So I will write like this. Sir, 1 ampere. Second one, I2. I2 is how much? It is 12 minus 20 by 2, no? It is minus 8 by 4. No, it is wrong, no? It is 20 minus 12, no? 20 minus 12. It is 20 minus 12 divided by, it is this one, 20. 20. It will be how much? 8, no? Yes, sir. It will be 8 divided by 20. So 0.4, 0.4. It is 0.4 ampere. 0.4 ampere. Then third one, I3. I3 means it is 2 minus x. 2x. X is how much? But it is 12 minus x, no? No. It's 12 minus x. This one is 12. It is 12. X is 20. It is minus 8 by 20. It is minus 0.4. Minus. This one is how much? 2 minus 20 by 30. It will be how much? Minus 18 by 30. That is minus 0.6 ampere. Why the current is minus? It is not, it is magnitude. Minus doesn't mean it is magnitude. It is your direction. So look, if we are writing 12 minus x, so we have thought about, sir, it will flow from this way, no? But it came out to be negative. Negative simply means it is wrong. So the correct direction will be like this. It is how much? 0. Plus 0.4 ampere. Same, we have think about this direction, but it came out to be negative. It is wrong. Wrong means the right direction should be like this, 0.6 ampere. Now look, 1 ampere is coming, 0.4, 0.6. That is 1 ampere is leaving the junction. 1 ampere is coming and 1 ampere is leaving the junction. This is all about the Kirchhoff's current law. It is what? Kirchhoff's current law. I guess it is clear to you now. It is Kirchhoff's current law. Easy? Let's do one more numerical. Let's do one more numerical. Okay? Or I can do one thing. Now I will be giving this one to your homework, right? So that you can just revise this one, and next time in next class I will be doing homework. Then we can do the next class. Okay? Look now. Done? This is my x point. X. Find x and current. Okay? Find x. Second one, current in all branches. Hint. Hint is potential at this point assume as 0. No. Hint, I have given you the hint that you need to assume that potential at this particular point is 0. Okay. So tomorrow we will discuss this numerical. Done? Let us start now. KVL. Take the screenshot of it now. Start now KVL. It is very easy now. Start with KVL now. Then Kirchhoff's voltage law, also known as second law. Second law, also known as loop law. Numerous names for a single law. Kirchhoff's voltage law, second law, loop law. One thing that you need to remember firstly, that it is based on energy conservation. This one is based on energy conservation. Energy conservation. Done. Second point. In a loop, loop means it is a closed figure. Starting and the ending point is same. Okay, I will show you now. In a loop, summation of potential differences is equal to 0. In the previous was summation of current at a junction is 0, but here summation of potential difference in a loop is 0. And you will get this, you need to get a sign convention is also sign convention. That is, if you are going negative to positive in a battery, if you are going negative to positive in a battery, your potential difference will be positive. So delta V becomes positive. If you are going from positive of your battery to negative terminal of your battery, your potential difference will be negative. Okay. If you are going along the current, if you are going along current, if you are going along current, so your delta will be minus IR. Okay. If you are going opposite to current, if you are going opposite to the current, opposite to the current, so your delta will be plus IR. These are some sign conventions that you need to keep in your mind. What, sir? If you are going negative potential difference to positive potential difference of a battery, so potential difference is positive. If you are going positive to negative, it will be negative. If you are going in the direction of current, your delta will be negative. If you are going opposite to the current, it will be positive. These are some sign conventions. Now I will show you a numerical by which you will get your thing is clear. Numerical is, let us suppose numerical is like this, no? Just like previous one. Okay, look now. So this was 20 volt, 40 volt, 1 ohm, 2 ohm, and 2 ohm. Look, if we are using KCL or KVL, functioning is same. We will get the current and we will get a potential difference, right? So now it is up to you which law you can use for your better understanding, for your shortcut method to get your numerical done. Okay, it is up to you now. I will show you the both, how to apply the both in a formula, in a numerical. Then it is your choice which one is very feasible for you. Now we have a loop, like we have a structure like this, and we have to find out potential of an unknown point. Of, if not potential, then current. Potential is means current now. Current, how to find the current? Let us suppose, let us assume that the current flowing from this one is I. It is basically an assumption. So this I current will flow through this one and this one now. Here we have a two ways. So if I write, sir, I1 current will flow through this one. So this one will be I minus I1. I minus I1. Okay, look now. Look now. Sir, if this point is A, sir, if this point is B, sir, if this point is C, if this point is D, this one is E, this one is F. How many loops we have? We have three loops. One loop is this one. Second loop is this one. Third one is this one. Okay. How many loops we have? Sir, three loops. Let us suppose we will take this loop firstly. This loop. This loop. Which loop we are taking? Sir, loop. If we are going from A to B, B to C, C to D. Then A, suppose. This loop. So one thing that we know that in a loop, summation of all the potential differences is zero. Okay, look now. If we are going from A to B, so what will be delta V? Sir, delta V is IR. I is 1 or R is 2. Is it 2I? But we are going along the current, it will become minus 2I. So it will become minus 2I. Now current I1 flows like this and we are going in this direction. It will be how much? Minus 1 I1. It is I1. So I will write here how much? Sir, minus I1. Then it is negative to positive. So my potential difference is positive. I will write plus 20 is equals to 0. So I will write 2I plus I1 minus 20 is equals to 0. First equation. It will take some time. Now it is some sort of confusing. It will take some time. Now second one. If you are going loop, which loop now we are trying it? Which loop? This one. We are going B, then E, then F, then C, then B. Okay. We are going in this way. Done? Look beta. We are going. Okay, it's like this now. We are going from B to E and same current is flowing from B to E. So what I can write? It is minus 2 I minus IY according to the sign conventions. Now we are going from positive to negative. It is minus 40. Done? Then look, current will flow like this B to C, but we are going from C to B. It is positive. It is plus I1 equals to 0. What I can write now? Sir, minus 2I plus 2I1 minus 40 plus I1 equals to 0. So I can write it is minus 2I plus 3I1 minus 40 equals to 0. Or I can write it is 2I minus 3I1 plus 40 equals to 0. Two equations, two variables. Yes, we can solve this one. We can two equations with two variables. Darshan Sindhi beta hai. Two equations, two variables, we can solve it, no? How? Look now. Look here. Let us suppose we will add. If we add equation first and second, it is 2I plus 2I. We will get nothing, no? With 2I, what we can get? 2I, then plus I1 minus 3I1. It is minus I1. We can do one thing now. Let us suppose we won't write this one now, this term. We'll take this one now. We'll take this one. One second, beta. 1 second. Okay. Now add. So it is 2i. Then we have plus I1 minus 20 minus 2i plus 3i1 minus 40 equals to 0. Cancel out. It is 4i1 minus 60 equals to 0. So I1 is equals to 60 by 4. 2 to the 4, 2 3 the 6 is 0. I guess it is 15 ampere. I1 is 15. If my I1 is 15, what will be I2 now? Look, sorry, I1 now. Look, it simply indicates this I1. This I1 is 15. It is 15. Now place I1 here. It is minus 2i plus 3. What is I1? I1 is 15 minus 40 equals to 0. Minus 2i plus 45 minus 40 is 0. Minus 2i, it will be plus 4, no? Sorry, 5 equals to 0. So I came out to be 5 by 2, it is 2.5, 2.5, but minus. It is 2.5, but minus. Done? 2.5, no? No, it is positive, negative. No, positive, sorry, it's positive, 2.5. That means this current is 2.5 and here it is 15. So we simply indicate this now that I minus I1. I can write I minus I1. I is 2.5, I1 is 15. I guess it is 12.5 minus. So the direction of, look now, I1 is this one. So I minus I1 will be like this. It will go like this. So this is how much? It is 2.5. This is 12.5. This one is 15. Okay. So this is how we can use our KVL, Kirchhoff's voltage law. Okay. If we are getting minus now, look, we have assumed direction of I minus I1 like this. But when we are taking it is magnitude, it came out to be negative. We simply indicate this direction is wrong. We have to take this direction. Done? How much time we have now? Oh, we have a lot of time now. One more thing. One more thing is we done KCL, KVL, but for KCL, KVL, we need loops. We need loops. But let us suppose we don't have any loop, we have a straight line. Let's suppose we don't have a loop, we have a straight line. How we can do it? Look, to find potential difference between 2 points. To find potential difference between 2 points. Okay, how we can do it? Okay, so you need to write potential of initial plus minus all potential differences equals to potential of final. Sir, what is the meaning of this particular one? Okay, potential of initial plus minus all potential differences equals to potential of final. It is one of the important one. Okay, how we can write? Look. If we have something like this, now, if we have something like this, A, this one is B, 3 volt, 2 ohm, 1 ohm. Done? And it is, so what we can write now? If current is flowing through this one, it is 2 ampere. Done now? So find for this one, find VA minus VB. VA minus VB. So what is VA? Sir, VA is this point. Okay, VA. Done. All potential differences. If we are going in the direction of current, potential is negative. It is minus IR. I is 2, IR is 2. Okay. We are going from negative to positive. It is positive, positive 3. Done. Current is like this. I. So it is minus 2 into 1 equals to VB. Done now. So VA minus 4 plus 3 minus 2 equals to VB. So I guess I can write VA minus 3 equals to VB. So VA minus VB equals to plus 3. And this is NEET PYQ. NEET PYQ. This one is NEET PYQ. Okay. This one is NEET PYQ. As you know that we are taking the class up to 12 o'clock. No? Up to 12 o'clock, I am taking the class. Then, tata, bye bye. Okay, let us do one more numerical based on this particular one. And this one is from JEE. JEE PYQ. JEE PYQ. Two ampere, 2 ohm, 3, 3, 2. This point is X. This one is Y. Find Vx minus Vy. If you want something, no, then you need to sacrifice your sleep, right? In our back in college, we used to sleep only for 3 to 4 hours. Still now, in this career, we are sleeping for 3 to 4 hours, no? Daily. Look, 3 plus 2, 5, 5. So equal resistance means equal current distribution. It simply indicates if 2 ampere is coming, so 1 ampere will go here and 1 ampere will go here, right? Now use the law. Initially this one, final is this one. So I can write Vx. Okay, current flow, if we are going in this way, let's in this way, no? In this way. We are going opposite to the current, so I will write plus. It is plus current into it is resistance. Now minus. Minus, look, we are going in the direction of current, it will be negative. So minus 3 into 1 equals to Vy. So Vx plus 2 minus 3 equals to Vy. So Vx minus Vy equals to plus 1 volt. It is plus 1 volt. Okay. Let us do a more difficult one. These were some easy, no? JEPYQ. These were some easy. Let us do one, a tough one. Okay, tough one. Let us increase the toughness of my numericals. X, 5 ohm, 5 ohm, 5, 5, 5, 5, 2 volt. This one is my numerical. And what we need to find? And this is Vy. I need to get Vx minus Vy. Okay? Vx and Vy. Sir, for Vx and Vy, I need current firstly. What I need? Current. Look, 5, 5, 5, 15, 5, 5, 5, 15. 15, 15, both are in parallel combination. Done? So what will be my R equivalent? It will be 15 by 2 ohm. Done? So what is V? V is IR. So I came out to be V by R. V is 2. It is 15 by 2. So I came out to be 4 by 15 ampere. My whole current is 4 by 15. If it is 4 by 15, that means 4 by 15 ampere is leaving and it gets equally distributed into 2 by 15 ampere and here 2 by 15 ampere. This is my initial point. This one is my final point. I can take any way. I can take any way. Either I will go like this or I can take like this way. It is up to me now. No constraint in taking these ways. Done? Okay, let's suppose I will take this one now. Suppose no. So can I write now? Can I write now? Vx, perfectly Vx. Current is flowing in this way. It is 2 by 15 ampere. And we are going in the direction of current. It will be minus. So I will write minus 2 by 15 into 5. Same this one, minus 2 by 15 into 5. Now, current will flow in this way. Okay. And we are going opposite. It is plus 2 by 15 into 5 equals to Vy. Cancel out. So Vx 5 and 5, 5 3 is 15 minus 2 by 3 equals to Vy. So can I write now? Vx minus Vy equals to 2 by 3 volt. Easy or super easy? Easy or super easy? Huh? Easy or super easy? This is what need PYQ. Now you are in a condition that you can do resistance problems, current one, current division, voltage division, no? And infinite ladder, finite ladder, and KCL, KVL, point potential method, symmetrical methods. Okay, these are some tricks that you need to use, no? Okay, so what we can do? So how many topics we have done? Now in we can end this class now because you need to sleep also now. So in tomorrow's class we will be doing Wheatstone bridge, okay, balanced and unbalanced plus cell. These two topics we will try to finish in tomorrow's class. Okay, this one. So in tomorrow's class, okay. So I can take, look, if you want to continue the session, I can take the Wheatstone bridge. If you like, I can take. No, there is no issue. Okay, you told me that you need to sleep also, right? So for that thing, I am just sacrificing my timing for your sleep, right? That's why. Okay. So you can do one thing now. But make sure that before coming to tomorrow's class, make sure that you can do the homework. Okay. And revise these notes so that it gets fit to your mind when to use KCL, when to use KVL, when to use this particular one, right? Now we have only 20 minutes now. So I guess Wheatstone bridge will take some time. Yes. But tomorrow is not my holiday. Na? I have my classes from morning to the evening, right? If you want to get better things, na beta, it is my advice to you, just repeat these things. If you are writing my notes, na, revise these things and how I am applying the formula. Look, I am giving you the different numerical so that you will get a different applicational part of it. Okay. If you can see now, if you can see this numerical, this one, and your homework numerical is same. Okay, so it simply indicates that you can apply multiple formulas to a single numerical. Okay, and at the end you need to decide now which formula you need to put now for your ease things. For today, it is more than enough. Tomorrow's class we will be discussing KV, sorry, Western bridge, balanced, unbalanced, cells. All these things we will discuss in tomorrow's class. And I hope that we need to finish the whole chapter within a couple of days. It will take more 3 to 4 days. Then we will complete the whole chapter. Then we will start capacitor. Okay. Thank you, beta. Bye. Good night, beta. Bye.